A star this bright should not still exist. The sun is about 4.6 billion years old. That number sounds stable, comforting, permanent. But in the late 1800s, the best physicists on Earth reached a terrifying conclusion. Our sun did not have enough fuel to survive that long. Based on the laws of physics known at the time, it should have burned out after only 20 to 30 million years, not billions, millions. That is not a small mistake. That is a complete collapse of understanding, because life on Earth is far older than 30 million years. Fossils, rocks, and entire layers of geology prove it. Evolution itself depends on deep time, which means one of two things had to be true. Either physics was wrong, or the sun was hiding a secret no one understood, and that secret changed science forever. In this video, you will discover why some of the smartest scientists in history believed the sun was dying, how a serious crisis shook the foundations of physics, and how a single equation rewritten in the early 1900s unlocked the true engine of the stars. You will learn about the hidden battle happening inside the sun right now, a battle between gravity and nuclear force that keeps our world alive. You will also uncover a lesser-known mystery called the faint young sun paradox, a problem that suggests the early Earth should have been frozen solid even while life was beginning. And by the end, you will see why the sun is not just a glowing ball of fire in the sky, but a ticking cosmic clock that controls the future of our planet. Stay with me until the end, because the final truth about the sun's life and death changes how you see every sunrise. During the 19th century, science was advancing fast. Physicists like Lord Kelvin tried to calculate the age of the sun using the best equations available. He assumed the sun was powered by gravity, slowly shrinking it over time. That process can release energy. It made sense. Using this model, he calculated that the sun could shine for only about 20 to 30 million years. At the time, this was considered solid science, careful math, clear reasoning. But there was a problem growing quietly in the background. Geologists were studying rock layers and realizing Earth itself was far older. Then Charles Darwin published his theory of evolution, which required hundreds of millions of years for life to develop slowly through natural selection. Kelvin's numbers did not allow enough time, not even close. Physics and biology were now in direct conflict. One of them had to break. The crisis was real. If Kelvin was correct, evolution could not work the way Darwin described. If Darwin was correct, then physics was missing a fundamental piece of reality. For decades, no one had the answer. The sun kept shining, but the explanation did not hold. The assumption that the sun burned like coal or wood turned out to be deeply wrong. Chemical reactions, even massive ones, simply cannot power a star for billions of years. The energy required is far too large. The missing piece would not appear until scientists began to understand the atom itself. Everything changed in the early 20th century. The discovery of radioactivity revealed that atoms contained enormous hidden energy. Then Albert Einstein introduced a simple but explosive equation, E equals mc squared, energy equals mass times the speed of light squared. A tiny amount of mass could be converted into an enormous amount of energy. This was not chemistry, this was nuclear physics. Inside the sun's core, hydrogen atoms fused together to form helium. In that process, a small amount of mass disappears. It does not vanish. It transforms into pure energy. That energy radiates outward and eventually reaches Earth as sunlight. The sun is not burning fuel the way fire burns wood. It is converting matter into energy through nuclear fusion. That discovery solved the age crisis. The sun finally had enough power to last billions of years. Yet, even this solution carries tension. Fusion does not happen easily. The sun's core reaches temperatures of about 15 million degrees Celsius. The pressure is so extreme that gravity tries to crush the star inward while fusion pushes outward. This balance keeps the sun stable. If fusion slowed down, gravity would compress the core and heat it up, speeding fusion back up. If fusion sped up too much, the star would expand and cool, slowing fusion down again. It is a delicate equilibrium, a self-regulating nuclear reactor floating in space. One small shift in this balance could change everything. There is another twist that few people talk about. Billions of years ago, the young sun was about 25 to 30% dimmer than it is today. According to simple climate models, Earth should have been frozen solid under such weak sunlight. Oceans should have been ice. Life should not have formed. But geological evidence shows liquid water existed very early in Earth's history. This puzzle is known as the faint young sun paradox. Scientists believe greenhouse gases in the early atmosphere may have trapped more heat, preventing global freezing, but the full story is still being studied. Even now, the sun holds unanswered questions. Right now, the sun is about halfway through its life. It has roughly 5 billion years left before it runs out of hydrogen in its core. When that happens, it will expand into a red giant. It may swallow Mercury and Venus. Earth's fate is uncertain, but conditions here will become unlivable long before that expansion completes. Eventually, the sun will shed its outer layers and shrink into a white dwarf, a dense glowing ember slowly cooling in darkness. The star that makes life possible is also counting down. This is why the story matters. The sun almost died in theory because we misunderstood the laws that govern the universe. A single missing piece of physics once threatened to collapse our understanding of time, life, and evolution. The correction did more than fix a number. It revealed the true power locked inside matter itself. And it reminds us that even our brightest certainties can hide deeper layers of truth. By the end of this video, you will understand how close science came to getting the sun completely wrong, how nuclear fusion truly works, why Earth should have frozen billions of years ago, and what the future holds for our star. More importantly, you will see how fragile the balance really is. The light that wakes you up each morning is the result of forces pushing against each other with perfect precision. Welcome to our channel, where we explore the universe with clarity and depth. If you enjoy uncovering the hidden physics behind everyday reality and questioning the foundations of what we think we know, subscribe now and join us for the journey ahead. In the late 1800s, science faced one of its most uncomfortable crises. The sun was shining calmly above, but the equations on Earth were pointing toward disaster. One of the most respected physicists of that era, Lord Kelvin, decided to calculate how long the sun could possibly shine. He used the laws of thermodynamics and gravity, which were powerful and reliable. He assumed the sun produced energy by slowly shrinking under its own gravity. As it contracts, gravitational energy is released as heat and light. It was a reasonable idea. In fact, it was the best explanation available at the time. When he ran the numbers, the result was clear and confident. The sun could not be older than about 20 to 30 million years. That was the maximum. After that, it would cool down and fade. According to the most advanced physics of the 19th century, the sun was young and short-lived. At first, this calculation seemed solid. Physics was considered precise. Mathematics did not lie. But another branch of science was quietly building a very different timeline. Geologists were studying rock layers, erosion rates, and sediment deposits. They saw evidence that Earth had gone through slow, gradual changes that required vast stretches of time. Mountains rose and eroded. Oceans formed and shifted. Fossils were buried deep beneath ancient layers of stone. The planet did not look millions of years old. It looked ancient. Estimates began to push Earth's age into the hundreds of millions of years. Later, with better measurements, into the billions. That created tension. If Earth was billions of years old, how could the sun be only 30 million years old? Earth depends on sunlight. Without the sun, life collapses. The timelines did not match. Then biology entered the conflict. In 1859, Charles Darwin published his theory of evolution by natural selection. Evolution works slowly. Small changes accumulate over immense periods of time. Species branch, adapt, and transform across geological ages. Darwin did not calculate an exact age for Earth, but his theory required deep time. Hundreds of millions of years were not enough. Billions made more sense. Kelvin strongly disagreed with Darwin's implied timeline. From Kelvin's perspective, biology was ignoring the laws of physics. From Darwin's perspective, physics was limiting reality too narrowly. Two pillars of science stood face to face, each backed by evidence, each confident. This clash became one of the most serious paradoxes of the 19th century. If Kelvin was right, evolution did not have enough time. If Darwin and the geologists were right, then Kelvin's physics was incomplete. The core mistake was simple, but invisible at the time. Scientists assumed the sun burned like a fire, not exactly like a campfire, but powered by chemical processes similar in nature. Coal burns by rearranging chemical bonds. Wood burns the same way. Chemical reactions release energy when atoms combine differently. These reactions can be powerful, but they are limited. The amount of energy released per kilogram of fuel is small compared to what a star produces. If the sun were powered by chemical burning, even if it were made entirely of the most efficient chemical fuel possible, it would exhaust that fuel quickly on cosmic timescales. Millions of years, not billions. The brightness of the sun was simply too great. The math did not work. Yet in the 1800s, no one knew what alternative existed. The atom itself was still mysterious. Electrons had not yet been discovered. The nucleus was unknown. Radioactivity was not understood. Scientists were trying to explain a star with incomplete tools. The breakthrough began at the turn of the 20th century. Experiments revealed that atoms were not solid, indivisible spheres. They had internal structure. Radioactive elements released enormous amounts of energy from their cores. This was not chemical energy, it was something deeper. It came from inside the atom. Then came a revolutionary equation from Albert Einstein in 1905. E equals mc squared. Energy equals mass times the speed of light squared. The speed of light squared is a massive number. This meant even a tiny amount of mass could convert into an enormous amount of energy. Matter itself was a form of stored energy. That idea transformed physics. Suddenly, a new source of power became possible, not chemical burning, nuclear transformation. Inside the sun's core, conditions are extreme beyond normal human experience. Temperatures reach around 15 million degrees Celsius. Pressure is crushing. Under these conditions, hydrogen atoms move so fast that they overcome their natural electrical repulsion and collide. When they collide with enough force, they fuse together. 4 hydrogen nuclei combine through a chain of reactions to form helium. During this process, a small fraction of their mass disappears. It is not lost, it becomes energy, exactly as Einstein's equation predicts. That energy travels outward from the core as radiation, eventually reaching the surface and streaming into space as sunlight. This process is called nuclear fusion. It is not fire, it is not combustion, it is the merging of atomic nuclei. The sun is powered by the transformation of matter into energy. Fusion solved the age paradox. Nuclear reactions release millions of times more energy per unit mass than chemical reactions. With fusion as its engine, the sun could shine for billions of years without running out of fuel. Kelvin's calculations were correct based on the physics he knew. The missing piece was nuclear energy. Once that was understood, the timelines aligned. Earth could be billions of years old. Evolution had enough time. Physics and biology no longer contradicted each other. The crisis slowly faded, replaced by a deeper and more powerful understanding of nature. But fusion introduces its own delicate balance. The sun is massive. Its gravity pulls everything inward, trying to collapse the star. Fusion in the core pushes outward, producing pressure from intense heat. These two forces oppose each other. Gravity compresses, fusion resists. When they are balanced, the star remains stable. If gravity ever gained the upper hand, the core would compress, raising temperature and pressure, which would increase fusion rates and push back harder. If fusion became too strong, the sun would expand slightly, cooling the core and slowing fusion down. This feedback system keeps the sun steady. It is a natural regulator. Fusion does not happen all at once. It proceeds slowly. That slow rate is crucial. If hydrogen fused rapidly, the sun would burn out quickly or explode. Instead, it consumes its fuel gradually, extending its life across billions of years. Even with fusion understood, mysteries remain. One of the most intriguing is the faint young sun paradox. Stellar evolution models show that billions of years ago, the sun was about 25 to 30% dimmer than it is today. Stars slowly brighten as they age because fusion gradually changes their internal structure. A dimmer young sun should have provided much less heat to Earth. Simple calculations suggest the planet's oceans should have frozen solid. A frozen Earth would not support early life. Yet geological evidence shows liquid water existed very early in Earth's history. Ancient rocks contain signs of flowing water and early microbial life. This contradiction creates another puzzle. If the sun was weaker, why was Earth not frozen? One possible explanation involves Earth's atmosphere. Early Earth may have had higher levels of greenhouse gases such as carbon dioxide or methane. These gases trap heat, creating a stronger greenhouse effect that could compensate for the dimmer sun. Another possibility is that cloud coverage, ocean circulation, or planetary albedo behaved differently in the distant past. Researchers continue to study climate models, rock chemistry, and ancient isotopes to refine the answer. The paradox is not fully resolved. It reminds us that even with fusion understood, the sun's relationship with Earth is complex. Today, measurements show the sun is about 4.6 billion years old. It formed from a collapsing cloud of gas and dust within our galaxy. Based on stellar evolution models, it has a total expected lifespan of roughly 10 billion years. That means it is about halfway through its stable hydrogen-burning phase, known as the main sequence. For the next several billion years, it will continue fusing hydrogen into helium in its core. Gradually, hydrogen in the core will decrease. Helium will accumulate. When hydrogen becomes scarce, the balance between gravity and fusion will shift. In about 5 billion years, the sun will enter a new stage. The core will contract under gravity, heating up further. Hydrogen fusion will continue in a shell surrounding the core. The outer layers of the sun will expand dramatically. It will become a red giant. Its radius may extend beyond the current orbit of Mercury and Venus. Earth's fate remains uncertain in detail, but conditions here will become extremely hostile long before any possible engulfment. Oceans will evaporate, the atmosphere will change, surface temperatures will rise beyond survival. After the red giant phase, the sun will shed its outer layers into space, forming a glowing planetary nebula. What remains will be the core, a dense object roughly the size of Earth, but containing about half the sun's original mass. This remnant is called a white dwarf. It will slowly cool over trillions of years, fading into darkness. All of this understanding stands in sharp contrast to Kelvin's original 30 million year limit. The sun did not almost die because it was weak. It almost died, in theory, because our understanding was incomplete. The age paradox revealed a missing layer of physics. Nuclear fusion was hidden inside the atom, waiting to be discovered. Once uncovered, it not only explained the sun's longevity, but also unlocked nuclear power on Earth and deepened our knowledge of how stars create the elements that form planets and life. The story of the sun's supposed early death is not a story of failure. It is a story of correction. It shows how science evolves. Observations challenge models. Models adapt. New evidence reshapes conclusion. The sun continues to shine above, not because it defies physics, but because physics turned out to be more profound than anyone in the 19th century realized. And the deeper lesson lingers quietly beneath the light. If the engine of all life on Earth was once misunderstood so completely, there may still be hidden forces and unseen mechanisms shaping the universe in ways we have yet to grasp. For billions of years, the sun has looked calm, steady, unchanging. It rises every morning without fail. It warms the oceans. It feeds the forests. It powers every breath you take. It feels permanent. eternal. But that stability is an illusion built on balance. Deep inside its core, gravity is constantly trying to crush the star inward. At the same time, nuclear fusion is pushing outward with equal force. One side compresses, the other resists. That perfect tension is what keeps the sun alive. Not too much fusion, not too little gravity. Just enough of both. A cosmic equilibrium holding back collapse and explosion at the same time. If gravity ever wins, the core shrinks and heats until new reactions ignite. If fusion ever weakens, gravity tightens its grip. If fusion ever surges too strongly, the star expands and cools. It is a self-regulating system, a silent battle that has lasted 4.6 billion years without pause. Every second, 600 million tons of hydrogen are fused into helium. Every second, a small amount of mass disappears and becomes pure energy. That energy travels across 150 million kilometers of space and reaches your skin as sunlight. Life depends on that balance continuing. Civilizations rise under it. Oceans remain liquid because of it. The food chain exists because of it. But this balance is not forever. The fuel in the core is slowly being used up. The clock is moving forward even if we cannot feel it. In about 5 billion years, the equilibrium will break. Gravity will begin to win in a new way. The sun will expand into a red giant. The inner planets will face destruction. Earth will no longer be the blue world we know. Long after humanity is gone, the sun will shed its outer layers and shrink into a white dwarf, a dense glowing ember drifting through space. The warmth that once sustained life will fade into a quiet remnant. Right now, the sun feels dependable. It feels like the one constant in a changing world. But its stability exists only because opposing forces remain in perfect balance. And that balance has an expiration date. The same physics that saved the sun from dying too young ensures that one day it will age, transform, and end its main sequence life. The star that gives us life is also a ticking clock. If this changed the way you see the sky above you, if it made you realize that even the most stable things in the universe are temporary, then stay with us. This is just one story hidden in the light of a single star. There are many more waiting to be uncovered. Subscribe to the channel so you don't miss the next journey into the deeper truths of our universe. Like this video if you learn something new, and share it with someone who looks at the sun and sees only light, not the powerful forces shaping our existence.